All right, day 16, we're going to be looking at pages 31 through 34 in your book. So go ahead and have that out so we can kind of refer to it. We're going to be talking about lines in a plane. Guys, once again, a lot of this should be kind of review for you, but if not, that's why we're going over it before we actually get into the pre-calculus stuff. All right, so slope of a line. The slope of a non-vertical line is the ratio of the amount of vertical change to the amount of horizontal change between 2 points. You have always been taught rise over run. So how many do you go up? How many do you go over? So let's look at the green box, the definition of the slope of a line. The slope is a non-vertical line through the points x1, y1 and x2, y2. So I would subtract my y's over subtract my x's. If the line is vertical, meaning straight up and down, then it's going to, x1 is going to be equal to x2. And the slope is going to be undefined. Alright, so if it's vertical, the slope is undefined. So find the slope of a line. Alright, this is pretty simple. If I'm given the points -1, 2, and 4, -2, then I would simply subtract my y's over subtracting my x's. Now, here's the one thing you've got to make sure you remember. It does matter the order. Alright? If I start here and I say 2 minus a -2, then I have to start with the -1 on the bottom. So then I would do -1 minus 4. 2 minus -2 is 4 over 1. -1 minus 4 is -5. So my slope would be -4/5. Okay? It does matter. Alright? 1 and 3, 4. Alright, so 4 minus 1 over 3 minus 1. That gives me 3 over 2. So the slope for that line would be 3/2. Alright? It's a positive slope. What would they look like on a graph? Well, if I were to graph -4/5, choose a point and start, all right, and then you would go, remember rise, so up 4, and because it's negative, you would go to the left, all right? So if I chose, let's just say, I chose to start here. I go up 4, 1, 2, 3, 4, and over to the right, or I'm sorry, over to the left 5. 1, 2, 3, 4, 5. So it would be here. So my line would look like this. It's going down, so I know it has a negative slope. What would 3/2 look like? So choose a point. I'm going to rise 3, 1, 2, 3. I'm going to go to the right 2. So I could go down 3, 1, 2, 3, 1, 2. So this one's going to have a positive slope. It's going to go up. And they've graphed them in your book also, so you can see that. All right. Figure P.23 shows a vertical line. Remember we said vertical lines have undefined slopes. So what happens if we're given the slope of a line, a slope of a line and 1 point, and they want to know what's the other point of the line? So here's what we can do. We have what we call the point-slope form of an equation of a line. And here is our point-slope form. Y minus y1 is equal to m times x minus x1. The y stays. The m is your slope. And this x stays. And then I'm going to put in a y coordinate here. And I'm going to put in an x coordinate here. Okay? So, these two things stay as x and y, and everything else is going to get something put in there. Alright, so let's say that I'm given a line that passes through the point -4 or -3, -4, and it has a slope of 2. I'm going to use the point slope formula to find the equation of this line. Alright, they want to know what's the equation. Alright, so I told you the y stays. I want to put in my y coordinates. So y minus -4 is equal to my slope times my x stays minus my x coordinates. Now I'm going to clean this up. So y plus 4 is equal to 2 times x plus 3. I can leave it this way, but most of the time we go ahead and use that distributive property. Y plus 4 is equal to 2x plus 6. And then most lines that we see are written in y is equal to mx plus b. So in other words, let's get rid of that 4. Y is equal to 2x plus 2. That is the equation for that line. Alright? Slope-intercept form equation of a line. The y-intercept of a non-vertical line is the point where the line intersects the y-axis. If we know the y-intercept and the slope of the line, we can apply the point-slope form to find an equation of the line. Alright, so here is my slope-intercept form. Y is equal to mx plus b. Now, let me flip this over. Y is equal to mx plus b. So let's talk about what we do here. That y stays. M is my slope. The x stays. And the b is the y-intercept on the graph. Okay? So write an equation for the line with the slope of 3 that passes through the point -1, 6, using the slope-intercept form. So they now specifically tell us we want it to look like y is equal to mx plus b. So I have to remember that point-slope form. Y minus y1 is equal to m times x minus x1. Alright, fill in what I know. Y minus 6 is equal to 3 times x minus a -1. So y minus 6 is equal to 3 times x plus 1. Y minus 6 is equal to 3x plus 3. Add 6 to both sides. Y is equal to 3x plus 9. I now know that B is 9, which would help me then to graph this, if I wanted to graph this, I know that it's going to go through my y-axis at 0, 9, because that is where it intercepts the y-axis. So now that gives me a starting point, and I know that my slope is 3 over 1, so I would go up 3 or down 3 and over 1. Down 3 over 1. So this is what my line would look like if I graphed it. We cannot use the phrase, the equation of the line, because each line has many different equations. Every line has an equation that can be written in the form of ax plus by plus c is equal to 0, where both a and b are not 0. The form is called the general form of the equation of the line. All right, I'm on page 34. If b is not equal to 0, the general form can be changed to the slope-intercept form as follows. Ax plus by plus c is equal to 0. I can subtract the ax and subtract the c, and that gives me by is equal to negative ax minus c. Divide everything by that b, because remember, a, b, and c right now are just numbers. We're just replacing those with letters right now. So divide everything by b, and I get y is equal to negative a over bx plus negative c over b, and that gives you your slope and your y-intercept. Guys, that green box, general form, slope-intercept form, point-slope form. Vertical line is x is equal to a. Horizontal line, y is equal to b. All right? So if it's a vertical line, it's going to be x is equal to something. If it's a horizontal line, it's going to be y is equal to something. All right, that is all for this lesson. Please make sure that you do the few problems that I asked you to do. And then you'll have homework tomorrow night for this lesson.